Okay, now we will move to advanced automation function. So these functions are not specific to particular work cycle or particular work unit. So they are functions that are concerned with enhancing the safety and performance of the equipment. So this includes safety monitoring, maintenance, repair and diagnostics, as well as error detection and recovery. So they are made possible by special subroutines included in the program of instructions. So this, for example, includes reporting a list of preventive maintenance tasks that should be accomplished, and usually it does not involve any physical actions by the control system, and it just provides information to the human operators, and therefore actions are taken by human operators and managers of the system. Okay, so let's take a look at the safety monitoring. Okay, so one of the significant reasons for automating manufacturing operation is to remove workers from hazardous working environment. Okay, so it is installed, or automation system itself is installed to perform a potentially dangerous operation. Okay, that would basically, if we would do it manually, it will harm the worker itself. So there are two reasons we are looking at the safety monitoring capability, which is to protect human workers in the vicinity of the system and to protect the equipment associated with the system. So safety monitoring itself involves the use of sensors to track the system operation and identify conditions and events that are unsafe or potentially unsafe. So possible responses to various hazards in the automated system might include completely stopping the system itself, sounding an alarm, and reducing the operating speed of the process. Okay, so sensors for safety monitoring range from very simple devices to highly sophisticated system. So some example of kind of very simple devices is limit switches, which is to detect proper positioning of a part in a work holding device so that the processing cycles can begin. And more advanced sensors are typically like pressure sensitive floor pads to detect human intruders in the work cell, or the machine vision system to perform surveillance of the automated system and its surrounding. So the limitation of safety monitoring system is basically defined by the designer. So it's like if the designer does not anticipate a particular hazard and did not provide the system with sensing capability to detect that hazard, then the safety monitoring system cannot recognize the event, even if it is occurring in the process. Okay. So the most sophisticated part of the safety monitoring is basically taking corrective actions to recover from safety violation, and this is basically a factor that determine the intelligence of the machine to perform some advanced strategy. So it's not necessarily confined to safety issues, and basically this leads to a more important or a more high level advanced function that we call error detection and recovery. Now, the second functions that are concerned with enhancing safety and performance of the equipment in automation is maintenance and repair diagnostics. So for maintenance and repair diagnostics, we have three modes of operation. So when we talk about maintenance and repair, it refers to the capabilities of the automated system to assist in identifying the source of potential or actual malfunctions and failures of the system. So these three modes, which is status monitoring, failure diagnostics, and recommendation of repair procedure, are typical of a modern maintenance and repair diagnostics subsystem. So in status monitoring mode, the diagnostic subsystem monitors and records the status of key sensors and parameters of the system during normal operation. So it serves two important functions in machine diagnostics. First, providing information for diagnosing a current failure, and secondly, providing data to predict a future malfunction or failure. So when a failure of equipment occurred, it's usually difficult for the repair crew to determine the absolute reason for the failure and what steps should be taken to make repairs. So therefore, usually it is very helpful to reconstruct the event leading up to the failure. So the computer is programmed to monitor and record all the variables and draw logical inferences from the variable values about the reason for the malfunction. So this diagnosis helps the repair personnel makes necessary repairs and replace the appropriate components. The second function of status monitoring is to identify signs of an impending failure so that affected components can be replaced before the failure actually causes the system to go down. So therefore then the part replacements can be made during the night shift or another time when the process is not operating. The second one, the failure diagnostics is invoked when a malfunction or failure occurs. So the purpose is to interpret the current values of the monitored variables and analyze the recorded values preceding the failure so that the cause of the failure can be identified. In the third mode of operation, the subsystem will recommend to the repair crew the steps that should be taken to effect the repairs. Okay, so methods for developing recommendations are sometimes based on the use of expert system, which is you have a pool of repair experts that have a collective judgment and therefore decides on the steps in the computer program to suggest the repair procedure. Sometimes this uses an artificial intelligence techniques to come up with the recommendation. Okay, so that is the most important part, okay, in maintenance and repair diagnostics. Okay, so these three modes of operation are integral to make sure that we have an advanced automation function in our production system.